initiative to provide masterclasses on all the Olympiad topics for grade 1 to grade 10 so that you get a hold over the questions on what is the pattern of the questions that's going to appear in these examinations. So with this, let me quickly introduce myself. This is Trishita Majumdar here. I'm a teacher expert at Cuemath and my teaching experience is 4 years. And I primarily teach mathematics and reasoning to students from India and US. With this, let's look into our table of contents. Let's look into our table of contents for today. So we would be understanding symmetry, applications of symmetry in day-to-day life, the objectives that we are going to cover up in today's class, the problems which would be of the basic level and the advanced level, and learning outcomes. So with this, let's quickly proceed with something which is related to symmetry, and this would also help you to understand symmetry in a better way. Okay, so let's see what's written here. So it says that symmetry is what we see at a glance based on the fact that there is no reason for any difference. What does this exactly mean? This statement means that symmetry is a condition of an object or of a figure wherein you get back the same image even after trying to overlap them, or even after dividing them, or even after rotating them. It depends on what kind of symmetry are you applying. So these are a few examples that you could see here. You have a square and this is the line of symmetry. So if you divide the square into two halves by this line of symmetry, both of these halves are exactly similar to each other. When I say similar, it means that if you place one of the halves over the other, they would completely overlap. Okay, the same goes with the second one, third one, and the fourth one. Okay, so this situation wherein you will not be able to find any difference between the two parts of the figure is known as symmetry. Okay, all right, let's proceed further. Now with this, we are going to go ahead with the definition of symmetry, and I'm sure that most of you must have already understood it and you're already replying on the comment section. So I want all of you to be active enough and put up your answers on the comment section. And let's quickly look into the definition of symmetry. So symmetry means that one shape becomes exactly like another when you move it in some way, either turn or flip or slide. So as I told you, the symmetry does not depend upon the, it doesn't depend upon which side is the figure being turned to. Or is it being rotational, or is it being vertical or horizontal or diagonal? It does not matter. That's secondary. The major thing what you need to focus upon is if you have a line of symmetry, no matter from wherever it passes, the line of symmetry that is dividing the figure into two parts needs to be exactly same. When I say exactly same, it means that it should overlap on each other, okay? So with this, we are going to go ahead with some applications of symmetry in our real life. So reflection of trees in clear water and reflection of mountains in a lake. All of us come across these kind of situations almost every day, right? So this is something which is completely related to our nature. But this is the best example through which we could understand symmetry. Any reflection of an object, reflection of yourself, basically I could say water images. All the water images of an object are nothing but our real-time examples of symmetry. Okay, coming to the second one, wings of most butterflies are identical on the left and right sides. We all know that. So all of us must have definitely seen butterflies, right? And we know that there is a bisection, which is basically the butterfly's body, which is bisecting its wings, right? When I say bisection, because it's equally dividing the two wings into equal regions and equal shapes, I could say. Okay, that's why I say that a butterfly is symmetrical in nature. When you try to if you've ever seen, if a butterfly is not flying and is stable at a position, it usually closes its wings, right? I am sure that most of you must have seen. And it's not just with butterfly, but with any insect or any flies which actually has two wings. You may notice that sometimes these wings are closed. And when they are closed, they look like just one wing, right? It's because the two wings are overlapped with each other, and hence overall it looks like one part. Okay, so I hope this was quite relatable to your real lives, and if you think that you have more examples related to symmetry, then you can definitely go ahead and put it on the comment section, and we'll all look into it, and we'll also see what other examples comes in. Okay, so with this, let's proceed further. So here goes our objectives for today. So we are going to learn on lines of symmetry, and we are going to learn about rotational symmetry. So these are the two categories of questions which we are going to focus upon. So here goes our first one, that is rotational symmetry. Let's understand what's this. A rotational symmetry is the property a shape has when it looks the same after some rotation by a partial or complete turn. So what does this exactly mean is, suppose I have an object with me and I'm rotating it by some random angle. Okay. So basically when an object is rotated, there might be several shapes to the object. There might be a situation wherein the object might also look same after rotation. There might be certain situations that the object might change its shape after a certain rotation. Okay. For example, let me take a hexagon. So here you can see there's a hexagon. You could also take an example of a square. So if you have a square with you, and if you rotate it by, let's say 90 degree or 180 degree, at every point you are getting back the same shape, which is a square. So basically, what does this mean? It means that you're getting back the same figure again and again in one whole complete rotation. Okay. And the figures that does not give us same figure to the same, the figures that does not give us the same shape even on one complete rotation does not follows rotational symmetry. For example, you have triangles. So you can see this triangle. So when you completely rotate this, you still do not get back the same figure. All right. So I hope this was clear to all of you. Yeah, so as and when we keep moving further, I'll be explaining more things about rotational symmetry coming to the questions. Okay, and now with this, we'll go ahead with line symmetry. Also in rotational symmetry, we have a concept called order of symmetry. Well, I'm going to discuss about this when we get into the questions. Okay, so here goes our lines of symmetry. Let's see, what does lines of symmetry mean? It means that the line of symmetry can be defined as the axis or imaginary line that passes through the center of the shape or object that divides it into identical halves. When I say identical halves, which we were just discussing some time back about the butterflies and different things, it means that if you have these two halves, let's say that here you have two halves of a square. When you take these two parts and overlap with each other, they should overlap, okay? Let's say that you take these two parts of pentagon and try to overlap, they should overlap with each other. Or let's say kite, or let's say this is a heart, circle, and this curved shape. All of these are symmetrical in nature because the line of symmetry is passing through the center of the object and dividing them into two equal parts by shape, by size, by area, by rotation, by everything. Okay, I hope that's clear to all of you. Yeah, so with this, we are going ahead and starting with our first objective problems, that's on lines of symmetry. And slowly we'll be proceeding with our rotational symmetry and moving ahead with advanced problems. Okay, so here goes our first objective. Let's see, I want all of you to be active on the comment section and give all your responses there. Okay. So, ABCD is a kite in which AB is equal to AD and BC is equal to DC. Which of the following is the kite symmetrical about? Let me quickly display the options here. So, we have these four options: point O, diagonal BD, diagonal AC and side BC. So, they basically are wanting us to tell that by is this kite, so all of you can see ABCD is a kite. Is this kite symmetrical about point O? So there is no point O with us. We can assume this to be point O. Is it symmetrical about point O? Well, that would something be about rotational symmetry, wherein you rotate a figure with respect to its central angle. Diagonal BD. So if you see diagonal BD, this is the line. Is this dividing the two parts into equal shape or equal areas? No, right? ABD is definitely not equal to BCD. So diagonal BD cannot be the answer. Diagonal AC? Well, yes. If you look into diagonal AC, you have two triangles being formed. One is ABC and the other one is ADC. And they are definitely same because we know that AB and AD are equal and BC and DC are equal and AC is the common side between the two. So both of these triangles are congruent to each other by SSS congruence. So for all the students who do not understand congruence, do not worry. You would be learning about it in the higher grades. But for everybody who is already aware of what you mean by congruence of triangles, I hope you were able to relate. These two triangles are following side congruence and hence they completely overlap with each other, right? And if they are completely overlapping with each other, they are symmetrical, okay? And for all the others who do not understand what you mean by congruence of triangles, let me just show it to you visually. You all can have a visualization using this. Let's say if this is 5, this would also be 5 because it's told that AB is equal to AD. If this is 7, this would also be 7. And if this whole line AC is 9, so this is like a common line of both these triangles. This is like a common side of both the triangles ABC and ADC. So definitely if you take these individual triangles, they are same, right? So they have same dimensions, they have everything to be similar. So when you try to overlap them one above the other, they get overlapped and hence I could say diagonal AC is the one which is dividing the whole kite into two symmetrical shapes. Okay. I hope this was clear enough. Now let's proceed further. Which of the following letters of English alphabets have more than 2 lines of symmetry? So they are asking for more than 2 lines of symmetry. Okay. So let's look into the options here. So we have A, O, T, H. Let's see who gives the right answer here. Let me wait. Okay, is it going to be A? So I'm going to I'm going to draw some lines of symmetry for all of these. Okay, so for A, I could say that this is the line of symmetry because the vertical line is dividing my A into 2 equal halves. How about O? We can divide O in this way. And also we can divide O in this way about horizontal axis and also vertical axis. What about T? Would horizontal work? No, it would not give symmetry. But if we go by vertical axis, it does give. How about H? As you all can see, H can have this as well as this. Now from here, you can see that H is giving symmetry even when you're having the vertical symmetrical axis, and also it is giving us symmetry about the horizontal axis, right? And same goes with O. Now the question is, which of the letters have more than 2 lines of symmetry? Now let's get back to O. As you can see that O is a circle. So no matter at whichever direction you draw the lines of symmetry, it will always give you symmetrical shape, right? Whether you draw it here, whether you draw it through this point. And you can see that at any point, you can again have more symmetrical lines between these. As in, I can conclude that O is the letter which has infinite number of symmetrical lines. So hence option B is the one which has more than 2 lines of symmetry. So everybody who understood this, please do let me know on the comment section, and anybody who did not understand, please put your queries on the comment section and we'll be reverting back to it. Okay. I hope the question was clear. Now proceeding further, here goes our third question. A parallelogram has no lines of symmetry, 1 line of symmetry, 2 lines of symmetry, and 4 lines of symmetry. Careful. I would say that this is one of the questions wherein students make a lot of mistakes because they just consider a parallelogram to be a square or a rectangle and then think about the question. But no. When it's not specified to us if it's a square or rectangle, we cannot assume them to be any of those. So we have to stick to a general parallelogram. And how does a general parallelogram look like? It looks like this, right? So this is how a general parallelogram looks like. Now, if I have to check for symmetry. So let me go with horizontal axis. Now, as you all can see, if I take up this part, let me just name it A, B, C, D, and here I have M, N. If I take up A, B, N, M and try to overlap with M and C, D, does it get overlapped? No, right? Because they do not have similar shape. As I told you, it's not just important for the shapes to have equal areas. It's also important for them to have same shape so that when you place one part over the other, it has to get overlapped. So this is not happening, right? So this is the horizontal, and coming to the vertical line of symmetry, of course, this is again not happening. As you all can see, this is forming a trapezium. This is forming a trapezium. Again, when you try to overlap this, it didn't give us symmetrical shapes. Hence, option A is the answer. A parallelogram has no lines of symmetry. Okay? Alright, so I hope that was clear to all of you. Now, proceeding further, let's go ahead. Here goes our next question on rotational symmetry. Guys, if you're liking the session, please do hit the like button and also do share it with your friends and ask them to attend the classes and take the benefits of it, because this is the best preparatory course for your Math Olympiad sessions. You would get an idea on how are the questions going to appear. So, all right, with this, let's go and proceed. What is the order of rotational symmetry for the given diagram? Now, coming to order. What do we exactly mean by order of rotational symmetry? Let me tell you, if you have a particular diagram, okay, let's say that you have a square, all right, and now you are rotating this square about its vertical and horizontal axis. So when you rotate the square by 90 degree, it still gives us a square. When you again rotate it by 180 degree, it still gives us a square. By 270 a square, and by 360 it is giving us a square. So as you can see, in one whole rotation, it gave back, the square gave us the same figure back. There was no scenario that at this point of rotation, the square did not give us a square back and it was a different figure. We always got a square on every rotation. 90, for 90 degree also we got a square. For 180 also we got a square. For 270 also it was a square. And for 360 also it was a square. Okay, so what does this suggest? It means that the number of times you get back the same figure as the original figure in a complete rotation of that particular object, that determines what's the order of rotational symmetry. Okay, and as per this, a square is giving us back 4 shapes in one complete rotation, right? So I could say that the order of rotational symmetry for a square is nothing but 4. Okay. A square is the simplest example to understand what rotational symmetry is in terms of getting back the same figure. But you also have a lot of shapes which does not give you back the same figure when you rotate it maybe, once or twice at maybe 90 and 270 it doesn't give. At 180 and 360 it does give. So we are also going to do such kind of questions. Now let's see here. What is the order of rotational symmetry for the given diagram? Now, let me quickly put down the options here. 1, 2, 3, 4. As we all can see, here if you notice, when you are rotating this by 90 degree, how would the figure look like? Wouldn't it give you back the same figure, right? It would still look like the same figure. And when you rotate this again by 180 degree, I still would get back the same figure. The reason is because the size of these small squares and these lines are same. And hence on every rotation, I'm getting back the same figure. So this and this. So we saw that in one whole complete rotation, we got back same figures in every turn. So from here, what can I say about the order of rotational symmetry? I could say that the order of rotational symmetry is nothing but 4. I hope that was clear. Let's go ahead and see this. What is the order of rotational symmetry of the given regular hexagon? So here, as you all can see, for a regular hexagon, let me just show you something. Let me just draw this once again and show you. Let me divide these into some parts. So I'm just joining the diagonals. And we know that since this is a regular hexagon, each of this would be 60 degree, right? All of these would be 60 degree because each of the triangles inside are equilateral triangles. I could say this is 1, 2, 3, 4, 5, 6. Now let's say that I am rotating. So you can see that each of the angles are 60 degree. So the angle of rotation of a regular hexagon is 60 degree. And when you're rotating this by 60 degree, how would it look like? It would look like this. It would look like this. You would have the same shape, but what's happening? This position of 1, 2, 3, 4 and 5, 6 are changing. So the first piece, that is 1, would shift back here because we are rotating by clockwise 60 degree. 2 would come here, 3 would come here, 4 would come here, 5 would come here, 6 would come here. Now what if we are again rotating it by 60 degree? Now when you're again rotating it by 60 degree, how would it look like? It would again be a hexagon. And this time, what would it be? Again, when you're rotating this by 60 degree, there would be shift of these triangles. The 1 would come here, 2, 3, 4, 5, 6. Now, if you notice, to get back the same figure, that is 1 at this position, how many times do I have to rotate? You can yourself check that only at the 6th rotation. Only at the 6th rotation, please give it a try. In the next rotation, your 1 will shift again. In the next rotation, 1 will shift again. And slowly, this will keep shifting and it will get back to this position at 6th rotation. This is at 6th rotation. Okay. So at 6th rotation, you will have a hexagon like this, wherein you will again get back 1, 2, 3, 4, 5, 6. Right. So this was one whole rotation. We have made 6 rotations. 6 as in one whole revolution contained 6 parts. That's because we are rotating it by 60 degree, and we know that one complete rotation is 360 degree. So 360 divided by 60 gives us 6. And at all of these 6 diagrams, in all of these 6 diagrams, we always got back the same original figure. That's nothing but the hexagon. So what can we say about the order of the symmetry? I could say that the order of the symmetry, rotational symmetry, is nothing but 6. Because it gave me 6 in all the times. Okay. So I hope that was clear enough. Let me put down the options. So option C is the right answer from here. Okay. So I hope this was pretty clear to all of you. Now moving ahead with the next part, that's the advanced level. So here, this goes our first question. After rotating a figure by 45 degree about its center, it looks exactly the same as its original position. At what other angle will this happen again? So let me put down the options here as well. So just think about it. If you're rotating an object by 45 degree and if it's giving back the same figure, then after rotating it by, let me show it to you. Yes. So you initially had 0 degree and then you had 45 degree. So let's say that at 0 degree you had some object, at 45 degree also you had an object. So at 45 degree you're getting back the same figure. So when I add 45 more to this, I get 90 degree. So at 90 degree also I would be getting the same figure, because at every 45th degree rotation I'm getting back the same figure. That's what this question suggests, right? And then again, if I add 45 degree to this, how much would I be getting? I would be getting 135 degree. So every time I'm adding a plus 45 degree, I'm getting back the same figure. So this is again plus 45 degree. And again to this, when I'm adding plus 45 degree, I would be getting 180. And then again add 180 degree when I add a plus 45. Yes. So this would become 5. And then yes, 225 degree, correct? And this with this again, when I add a plus 45, how much would I be getting? I would be getting a 270 degree, and this keeps continuing, right? So if you notice, they are asking at what other angle will this happen? So we notice that on every 45th angle's rotation, we are getting back the same figure. So among all of these, we have 90 as well, we have 135 as well, we have 270 as well. So as in, can I say that option D is our right answer? That's all of these. Yes. I hope everybody enjoyed doing these kind of questions. So please put your comments on the comment section, and now we'll be proceeding further with the next question. So here goes our next question. The number of English alphabets that do not have any lines of symmetry is. So for this, I would like to give a task to all of you. Write down all the letters from A to Z and check which of the letter follows rotational or line symmetry. We have already done an alphabet related question in the beginning of the session that's on line symmetry. So try to figure out which all letters does give you line symmetry or rotational symmetry. So any other alphabet that's not any letter that's not giving you any of the two symmetries are the letters which does not follow any lines of symmetry, right? And for this, let me write down the letters that does not follow any line of symmetry. And what you all can do is, you all can, maybe after this session sometime, you can write down all the letters from A to Z and check with the symmetries for each and every letter, okay? So we have F. So all of you can try to figure out the symmetry for these, okay? So we have F here, we have G here, and then we have J, and then we have L, and then we have N, P, Q, and we have R, we have S, and we have Z, okay? So if you look into these, if you look into F, either ways you will not be able to have symmetrical shapes no matter however you try to divide it. Same goes with G, J, L, N, P, Q, R, S, Z. So altogether, these are the set of letters which does not follow any lines of symmetry. This question is very common and very important as well. Many times this could be asked. So you could just remember it as the value and the letters that does not follow any symmetry. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So out of option A, B, C and D, we have option B as the answer, which is nothing but 10. I hope that was clear enough. So this is our last question for the day. State true or false for the following questions. Equilateral triangle has 2 as an order of rotational symmetry. Let's check this out. Let's say that this is an equilateral triangle and let's draw the medians of these equilateral triangle. Now, if you notice, when I actually divide this into its with respect to its respective medians, each of these angles are 120 degree because all the 3 triangles are equal, as in congruent. This is triangle 1, triangle 2 and triangle 3. All 3 triangles are congruent. So 360 divided by 3, each angle gives us 120 degree. So that means you are rotating this equilateral triangle thrice, right? And in one whole complete rotation, you are rotating this equilateral triangle thrice because 120 plus 120 plus 120. And when you're doing so, you get back the same figure in every rotation. All of you can check. Just like we had done for hexagon, regular hexagon. It's just that the faces 1, 2 and 3 would get shifted. But in all the 3 rotations, you're getting back the same figure. Hence, 3 is the order of rotational symmetry, not 2. Okay, so this is basically false. Coming to the second one, a regular polygon of m sides has m order of rotational symmetry. We have already done such examples. We took square. Square has 4 sides and we also had checked that when we rotate square by 4 times, we get back the same result. So order of rotational symmetry for square is basically how much? Basically, it is nothing but 4, right? Coming to the next part, that is I and O are the only letters that have 2 lines of symmetry. Really? No other letters? We do have. Okay, so we have H, we have X as well. As you all can see, H is also having 2 lines of symmetry. X is also having 2 lines of symmetry. Hence, I could say that this statement is also false. Coming to the second point which we had to state, that is regular polygon of m sides. So we just discussed about square and hexagon and also an equilateral triangle. Hexagon has 6 sides, 6 as order of rotational symmetry. Square has 4 sides, 4 as order of rotational symmetry, and triangle has 3 sides, 3 as order of rotational symmetry. So hence this becomes true. With this, let's go ahead with our learning outcomes and we'll be winding up the session for today. So here goes our first learning outcome. Learning how to draw lines of symmetry for various figures, how to analyze figures of rotational symmetry by rotating them, practice more number of problems to attain good speed. And with this, I would be winding up our session with an important announcement. So, Cuemath has launched the TUCO examination that is on Math Olympiad, and the examination is going to be held in the month of December and Jan. So, everybody who is interested can go ahead to the description box and click on the link to register. The registration amount is just 200 rupees. And once you register, you would also be provided with the Olympiad practice worksheets from Cuemath Sen, which is worth 5,000 rupees, and all of these just for 200 rupees. So if you did like the session, please hit on the like button and do share it with your friends. I'll see you in the next class.